In this video, we'll use the PASCO wireless magnetic field sensor to explore the magnetic field surrounding a coil. This 3-axis magnetic field sensor can sense the Earth's magnetic fields from current-carrying coils, and permanent magnets. It includes a USB charging cable and a mounting rod. We can use the sensor to explore the direction and strength of the magnetic field surrounding this coil, and discover the relationship between magnetic field and electric current. I have here a power supply and a coil. This is the PASCO Smart Power Supply and a 400-turn transformer coil, but you can use almost any low-voltage DC power supply and coil. Here in SparkView software, I've set up a page to control the voltage of the power supply and display the X and Y components of the magnetic field. I can look at the label to see the direction of the X, Y, and Z components. I'll turn on the power supply and start data recording. As you can see, the sensor measures a field strength of about 0 Gauss in both the X and Y directions. There are dots on the probe here to show the exact locations of the high and low range sensors. For this experiment, we're using the default 50 Gauss low range. If I put the sensor probe into the coil, it now measures about 40 Gauss in the X direction, but still 0 Gauss in the Y direction. If I put the probe on the outside of the coil, it now measures a negative value in the X direction at lower magnitude, and in the Y direction, it's still 0. Looking at just the X component, if I find a positive value inside the coil and a negative value outside the coil, there must be some location along this path where it's 0. That's right about there. You'll notice, however, that here the Y component is not 0. It's a negative value. If we move to the corresponding point on the other side of the coil, it's of a similar magnitude, but now it's positive. And the same thing if we move to the corresponding point over here. Now let's return the probe to the center of the coil. We can see that if I decrease the voltage, the magnetic field also decreases. And when the voltage goes negative, the magnetic field also goes negative. It's more relevant to look at current rather than voltage. So on this page, I've set up a table to display the current and the X component of the magnetic field. Let's see if we can discover the relationship by varying the current and measuring the magnetic field. So I'll collect a data point there, change the current a little bit, collect another point, and again, and one more. On the final page, I've set up a graph to show the data that we've just collected, and it shows a linear relationship between the magnetic field and the current. If you'd like more information about the wireless magnetic field sensor, or more experiments that you can do with it, visit PASCO.com. Thanks for watching.